Hi dear student, the continuation concept in the D block element chapter that already we discussed the preparations or manufacture of potassium dichromate. That's very important for 3 marks questions. Next, after that, the continuation part of this potassium dichromate. This potassium dichromate already I discussed the manufacture as well as the conversion of the chromate over to dichromate. The chromate, the Cr2O7, the Cr2O7 2 minus 2, CrO4 2. CrO4 2 minus. How this conversion already I explained. Yes, right. Once again I will tell you. You see here. This is what CrO4 2 minus is converted into Cr2O7 2 minus. This is depends upon pH of a solution. This is depends upon pH of a solution just. And also the oxidation number is this is also plus 6 and this is also plus 6. Therefore oxidation number of the these molecule will be same, and the conversion of chromate to dichromate ore is depends upon pH condition. Just already we learned in the previous video. Next, after that, in this video I will go for the what is the structure. What is the structure of this chromate ore and dichromate ore. The chromate ore, dear student, this is a tetrahedral shape. This is what a tetrahedral shape. This is what chromium structure O minus double bond O, and this is one more. This is what a tetrahedral shape. This is tetrahedral shape and sp3 hybridization compound molecule, dear student. Next, after that, this is for this one, chromium, oxygen, chromium. Next, one O minus double bond O, O minus double bond O, dear student. This is what and this bond angle will be 120 degree. You see here, this is the tetrahedral shape molecule, dear student. This is sp3 hybridized, and one chromate ore is here. One chromate ore combines with one more chromate ore with oxygen bridging. This is what bridge the oxygen, dear student. This bridge the oxygen in between the chromate ore and chromate ore. Therefore, this chromate ore tetrahedral shape, two tetrahedral shape molecules that join to form the dichromate structure. This is chromate structure, dear students. Therefore, this is what a structure of chromate and dichromate molecule. They are asking in your examinations for 1 mark that you write the structure of the chromate and dichromate structure. Next, after that, go for the use of this potassium dichromate. Potassium dichromate is first very important example. This is used in the primary standard. The first use is used as a primary standard. Primary standard in volumetric titration. Volumetric titration. You see here, already we know that titrations. In that titration, we are using one of the primary standard, one of them is secondary standard. Primary standard means what? Already we know that titration. Titration means we are adding the unknown to the known solution. Yes, right. Therefore, we are adding whatever unknown or known to the unknown solution. For example, what conical plus we are taking unknown. Whatever in the burette we are taking known solution. Yes, right. In that primary standard we are taking as a K2Cr2O7. K2Cr2O7 as a primary standard in any of the determining unknown solution. ಯಾವುದೋ ಡಿಟರ್ಮಿನ್ ಅನ್ನೋನ್ ಸೊಲ್ಯೂಷನ್ ಡಿಟರ್ಮೈನ್ ಮಾಡಬೇಕಾಗಿರ್ತದೆ, ಅವಾಗ ನಾವು ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್ ತಗೋತೀವಿ. ನೋಡ್ರಿ, ಇದನ್ನೇ ನಿಮ್ಗೆ PUC ಫಸ್ಟ್ ಇಯರ್ ಪ್ರಾಕ್ಟಿಕಲ್ಸ್ ಇರೋದು. FAS ವರ್ಸಸ್ ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್. ದ FAS ಮೋರ್ ಸಾಲ್ಟ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಮುಂದಿನ ಹೆಸರು ಮೋರ್ ಸಾಲ್ಟ್ ವರ್ಸಸ್ potassium dichromate. This titration they are asking in your practical also. That's very important, dear student. ನೋಡಿ, ಇಲ್ಲಿ ಈ potassium dichromate ಅನ್ನು primary standard ಆಗಿ ಯೂಸ್ ತಗೋತೀವಿ ನಾವು. And this one we are taking as a unknown FAS. Okay, this FAS is unknown. This primary standard is like potassium. Why it is called as primary standard? That what is meant by primary standard? That is also very important, dear student. Primary standard means what? Primary standard means the concentration of that solution will be known. ಯಾವ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 0.1 ನಾರ್ಮಲ್ ಐತು, 0.1 ಮೋಲಾರ್ ಐತು, ಈಗ ಎಷ್ಟು ಐತಿ ಅನ್ನೋದು ನಮ್ಮ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬಿಫೋರ್ ನಮ್ಗೆ ಟೈಟ್ರೇಷನ್ ಮಾಡೋ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗೊತ್ತಿತ್ತಂದ್ರೆ ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರಿಬೇಕು, ಪ್ರೈಮರಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್. ದ ನೋನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಪ್ರೈಮರಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್. ಇದು ನೋನ್ ಆಗಿರ್ತದೆ, ಇದು ಅನ್ನೋನ್ ಆಗಿರ್ತದೆ. This is what unknown and this is what known. Therefore, whatever we are doing the titration, it is called as elementary titration. Therefore, this type of titration you are using the K2Cr2O7 as a primary standard, dear students. Okay, ಯಾವುದೇ ಒಂದು unknown ಇತ್ತಂದ್ರೆ ಅದನ್ನ ಕ್ಯಾಂಡಿಡೇಟ್ potassium dichromate ಆಗಿ ಯೂಸ್ ತಗೋತೀವಿ. Next, very important. It's very important. Next, it used in the oxidizing agent. Oxidizing agent. What is mean by oxidizing agent? That is very important. What is mean by oxidizing agent? The compound. What is mean by oxidizing? Nodri, oxidizing agent already oxidizing agent. Nodri, if you don't know, I will do one separate video. What is mean by oxidizing agent? Reducing agent, oxidation, reduction, redox. I will do one separate video. You don't worry, but I will tell you this K2Cr2O7 act as a oxidizing agent. Oxidizing agent means what? It helps for the, or this agent itself, this oxidizing agent means these are the compound. This K2Cr2O7 is a compound which helps for the oxidation. You see here, which helps for oxidation and itself undergo reduction. Itself undergo a reduction. You see here. ಈ K2Cr2O7 ಐತೆ ಅದಕ್ಕೆ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಅಂದ್ರೆ ಅದು ಏನು K2Cr2O7 ಅದಲ್ಲ ಯಾವುದೇ ಒಂದು ಕಂಪೌಂಡ್ ಆಕ್ಸಿಡೈಸ್ ಮಾಡ್ತದೆ ಅಂಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಅದು ಏನಾಗ್ತದೆ ರಿಡಕ್ಷನ್ ಆಗ್ತದೆ. Therefore, this K2Cr2O7 is one of the good oxidizing agent. Good oxidizing agent. How you come to know that this is good oxidizing agent? This is very important, dear students. Those who are going to understand any of the chemistry concept, this if you don't know this, whenever you are learning chemistry, then chemistry of any concept that depends upon, or they are always with reactions proof are there. This note, you see here, this Cr2O7 2 minus combines with 14H plus and 6 electron. It gives rise to Cr3 plus Cr2Cr3 plus 7H2O. You see here, this is a basic fundamental equation, and where the K2Cr2O7 shows the oxidizing agent. This compound is showing the oxidizing agent. Yes, right. This compound K2Cr2O7 is act as the oxidizing agent. This is basic equation. Notice, here, one question: how this iodide ion converted into iodine? Explain in presence of K2Cr2O7 as an oxidizing agent. K2Cr2O7 an example ತಗೊಂಡು ಇದು ಹೆಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡ್ತೈತಿ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ ನಿಮಗೆ ಎರಡು ಮಾರ್ಕ್ಸ್. Explain the oxidizing nature of, otherwise they are asking question, explain the oxidizing nature of K2Cr2O7 while conversion of I minus to I2. They are asking questions like that also. Okay, ನೋಡ್ರಿ ಇದು ಬೇಸಿಕ್ ಇಕ್ವೇಷನ್. ಯಾವುದೇ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ಇದನ್ನು ಬರೀಬೇಕು. ಅವಾಗ ನಮಗೆ ಗೊತ್ತೈತಿ 2I minus converted into I2 where liberation of 2 electron. Yes, right, we know this. This is basic equation. Balance the electron. First here 6 electrons are here only 2 electrons. Therefore multiply this equation by 3. Yes, right, the multiply this equation by 3. Therefore write all these two equations again, once again. Therefore Cr2O7 2 minus plus 14H plus 6 electron gives rise to 2Cr3 plus 7H2O. To multiply this equation by 3, 6I minus converted into 3I2 plus 6 electron. To add up this equation, well, cancel the electrons. Yes, right. Therefore, to add this equation, this is what Cr2O7 2 minus plus 6I minus plus 14H plus converted into 3I2 plus 2Cr3 plus 7H2. This is what they are asking questions in previous also. They are asked 2 marks, 3 marks. explain the oxidizing nature of K2Cr2O7 with taking example. They are telling like this also, or they are asking questions like explain the oxidizing nature of K2Cr2O7 while conversion of I minus to I2. They are asking questions like this. We know that basic equation of oxidizing agent of K2Cr2O7, I2 minus to I2 conversion with liberation of 2 electron. Multiply this equation by 3. Why? Because there will be 6 electron. Multiply this equation by 3. Again I return this equation, same equation. This multiply 3. Therefore 6 electron, LHS are just same. Therefore 6 electron cancel. Therefore this is what total oral equation while conversion of I minus to I2 dear student. This is very important. Okay, one more I will solve this question. One more question I will solve. Explain the oxidizing nature of. Their question otherwise explain the oxidizing nature of conversion of Fe2 plus to Fe3 plus. Fe2 plus to Fe3 plus liberation of 1 electron. You see here only 1 electron liberated, here 6 electron. Therefore whole equation multiplied by 6. Therefore what happens? 6 Fe2 plus converted into 6 Fe3 plus liberation of 6 electron. Therefore this is what 6 electron cancel each other. Therefore Cr2O7 2 minus plus 6 Fe2 plus 14H plus, it gives us to 6 Fe3 plus 2 Cr3 plus 7 H2O. Okay, I hope everyone can understand it. ಏನು ಈ ರಿಯಾಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡಲಿಲ್ಲ, ಇದು ಬೇಸಿಕ್ ರಿಯಾಕ್ಷನ್. ಯಾವ ಕನ್ವರ್ಷನ್ ಮಾಡೋದಿರ್ತಾರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಆಗಿತ್ತು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು ಕ್ಯಾನ್ಸಲ್ ಮಾಡೋದು, ದಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ವಾಟ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆರ್ oxidizing property of K2Cr2O7 dear students. If you want to practice some of the other example, practice this SN2 plus 2 conversion of SN4 plus, next H2S2. Yes, there are so many examples are there, you have to practice. Otherwise 2Br minus converted into Br2, you have to practice some other 3, then only you are going to get the oxidizing nature of the K2Cr2O7. Okay, this is what K2Cr2O7 concept is over. And next video I will go for the potassium permanganate. That 2 video I will do. And after that this D block element chapter will be perfectly over. Okay, thank you for watching my video. If you like my video, please share, it will help to someone else. Okay, thank you.